so let's get to it. As you probably know by now, Rust doesn't have null at all. In some languages, when you want to assign something to a variable, but you don't have that value immediately, so you just assign it null. It's actually bad for business. Okay, so that is why Rust doesn't have null at all. In fact, you can take the word of Tony Hall, the man who actually created null sometime in the early 60s. He called that act of creating null a $1 billion mistake. And why? Simply because over the years, a lot of software has crashed because of what he created, which is null. It causes a lot of errors and all that, because once a variable is holding null, you can't use it for anything. If you use it, it's going to crash your code and all that. So Rust has intentionally avoided null altogether. Okay, now the question is, what replaced it? Well, that is what we are going to look at in this video. Okay, so the idea is that instead of null, we use enums. In case you don't know what enums are, you should check out this video that I dedicated to explaining enums. And the idea is that there will never be a point where you are trying to use a variable that doesn't exist in Rust. It doesn't exist. Okay, this makes Rust so safe, because once you're using a variable and the compiler allows you to use it, it means that variable contains the value you expect it to contain, which is very, very important. And in fact, let me show you how it works. Now, for example, in other languages, when coding, you might want to create a variable that will hold the price of a product, but you have to calculate it and add the shipping and all that. You could call it price, but because you don't have the value yet, you set it to null. Okay, now the problem is this: if you try to use this variable, maybe add it to something else while it is still null, it becomes a very big problem. It will crash your code. Okay, so Rust avoids this class of errors with a very intelligent move. So what they did is this: they created an enum that they called option, where you provide the type of that option, and then you have two variants. First will be none, okay, and then the second one will be some. T. In case you're wondering what this is, it's called generics. You're simply saying, whenever I'm going to use this enum, I will give it the type I want it to hold. Okay, what you then need to do here is to come in here. So instead of doing this, we'll do something else. Now we know that this variable should contain a floating point number, the price of the product. Okay, let's say after calculating it, it's going to hold $15. Now, the first thing we have to do is to give it a type. Okay, so we say it will hold a type option, and then the type will be F64, which is a floating type, and then we assign something to it. What we are going to assign to it will be none. Now, actually, this comes with Rust. Rust already have this implementation defined, so I just wanted to show you what it looks like. So I will just delete that, but let's just comment that. Instead of doing this, what we can do is we create the same variable. Okay, let's comment that one out, and then we set it to something special. We say it's going to be a type of option of F64. Okay, because that will be the price of the product will be of type floating point, like $15.0, and then we set it to something. But since we don't know what it's going to be, we just set it to none. And you might be wondering, none looks like null. That is actually true, but in this case, Rust will never allow you to use this variable anywhere unless you convert it to F64 value. Right now, it's just a variant, an instance of these options enum. Okay, now this way Rust will prevent you from ever using this variable unless you make sure it contains what it's supposed to contain. Okay, now for example, in order to use this variable, what we can do is this: we use the match statement, we use the match expression. You can check out this video where I explain the match expression in detail. Okay, we can use the match expression to check what price is, to make sure that price contains some value before we use it. And then what we then do here is this. We say if it is still none, it means it doesn't have any value. We just print something to the terminal. No value yet. Okay. But Rust will not allow you to. You can see if you hover over this, it will say missing match sum, which means you are just checking if it is none. You've not checked if it contains some value. This way it will force you to compare when it has some value and when it doesn't. That way you don't make the mistake and then your code will fail when it is running. So what we can then do is we use sum, and you know that sum will contain some value here. Okay, because we don't want it to contain anything, we can just pass this underscore for now, and then we can now print something. The value is, you can just change that to X for now and then use it here. And now Rust is happy. Now watch what will happen when we run this code. You see it says no value yet, because Rust, using this match expression, Rust has compared that and found out that the value is still none at this point. Now if later on we are able to calculate the value, we can now assign the value to the price. For example, here you could say price equal to sum, and then we say 15.0. Now because we still have to convert this price to mutable so that it will be changeable, now we can modify this to have it contain some value. And if we run this code again, we get the value is 15, which makes a lot of sense. You see, now it will never be possible for us to make any mistake and use this variable in the wrong way. So this is the whole idea of using the options enum as against introducing null in the Rust language. Now as you know, the match expression is also an expression, which means it can return some value. So later on you can just say the price and then you assign it to whatever this match expression will return, and all you have to do is to return 0 here. Okay, if you did not find any value, and then if it has some value, you just return that value here. Then down here, because it needs a float, we convert that to a float. If not, it's not going to work. Now if we print something to the terminal here, you see it says the price is 15. This way we are always safe to use the correct value. Now there is something else I need to point out. You can see here that we just used sum. Note that this is the same equivalent. This is the equivalent of saying option sum. So sum is a variant inside option, but we have the privilege to use it without calling it from this option. Okay, without going through the option enum, because it is loaded into the prelude. It simply means that Rust has loaded both sum and none for us, so that we have the privilege of using it directly instead of typing option.none :none. They are the same thing, but since this option enum is so important in Rust in its wisdom, or in the creator's wisdom, has decided to load this for us so that we can just use it directly without typing in the option enum. Now as you know, enums do have methods in Rust. Okay, the same thing with this one. You can see, let me demonstrate something. There are a few methods these options enum have. For example, you can check if something is none or not by just saying, you can say if price dot is none. So is none is a method inside the options enum. Okay, you can even check if it is sum. If it is sum, it means it contains some value. Okay, alright guys, thanks for watching the video. If you still have some questions about why null doesn't exist in Rust, or any other questions surrounding enums and every other thing in Rust, do let me know. Like the video and subscribe so you get notified when I release more videos.